Hey everyone. For those of you guys that missed class on Monday, Tuesday, and or just have come in late and missed some of the demonstrations, I'm going to do this in the video. On Canvas, make sure you guys are on our homepage and then come to the electrical fundamentals. Scroll down to circuits and then click on series circuit. And make sure that you guys have this document downloaded. This is a symbols document. I do want you guys getting used to what the symbols look like. Download this document. This document is a student handout and shows you the VIR rules, voltage, current, and resistance rules, and symbols. And then this right here is a link to the simulation. For those of you guys that want to try the simulation and do a plug and play and maybe check your math, you can build a circuit that looks exactly like the one that we're covering, and then you could check it and test it out. Okay. I'm not going to spend a lot of time showing you guys that. I'm just going to work on the math so I can get this over with, okay? All right. So once you guys have that document downloaded, this is the document that I want you guys to find, and that's that student handout. The first thing we need to look at is the rules for a series circuit. Okay, so a series circuit only has one path for the electricity to follow, okay, or to flow through. The first rule, sum of all resistance equals total resistance. So sum. Basically, all you're doing, guys, is adding up the sum, all of the resistors around that circuit, and that is your total resistance. It's actually pretty easy. Okay. Next rule, current is constant. Now, this is something that's going to be missing a lot of times, and you guys are going to have to be able to calculate it, okay? And that is, once you calculate it, current is constant. That basically means that it never changes. Whatever goes in is always going through the circuit, okay? Through all the resistors, coming out the resistors, through the lamp, out the lamp, it's the same. Which isn't entirely true, because when it hits resistors and it hits lamps, it does kind of trickle down a little bit, but not a whole lot, okay? The sum of all voltage is the total voltage. So what this means, guys, is you have to add up all the voltage in order to basically verify that that is how much volts you got going in. The trick here, guys, is a lot of people think that, yeah, you just need to add up the voltage and it's the same. So, but because you're going to know the voltage sometimes as you start. Most of the time, you'll know the voltage in just about every circuit. But what it's not telling you guys is there is a voltage drop across the resistors. This is why you have to add them up, okay? So I do want you guys to understand how to calculate that, okay? All right, so let's go ahead and get started. So this is the first circuit that I went through in class, okay? Over here, guys, this is that diagram, the pie chart that I was telling you guys about in class. And this one, this V, that stands for voltage. The I stands for current. And the R stands for resistance. When you're trying to solve for the unknown, the one thing that you're trying to solve for, all you need to do, guys, is cover up that letter, and whatever's left, that's the math that you do, okay? So for example, a lot of times in this one, we're going to be finding current, right? So if you cover up the I, pretend that you don't see the I, okay? And what kind of problem does that become? Well, that becomes voltage divided by R. If you cover up the R, let's say you're trying to find resistance and you're covering up the R. Well, what kind of problem is that? That's volts divided by current. And if it's volts that you're trying to solve for, right, you cover up that V, you pretend you can't see that V, and then what do you have? I times R, okay? So once you understand those three basic, transitions within that equation, you guys will be all right, okay? All right, so let's go ahead and look at this thing. Let's go ahead and look. We know that we're starting with 12 volts, okay? We got 3 resistors, and they are in series, okay? This is our lamp. These are the icons for a resistor, and this is the icon for battery right here, okay? So the first thing that I can do is I can go ahead and punch in this 12 volts, all right? Because I know that whatever I start with, that's my total voltage within this circuit. So I'm going to go ahead and put that in right here, 12, okay? This stands for voltage total. This stands for current total. And this stands for resistance total, okay? I always like to try to find the totals, if possible, before I go off into the circuit. The next thing that I need to do is add up my resistors. Why? because it tells me to. The sum of all resistance equals the total resistance. Okay, so that's 150 plus 250 equals 400 plus 400 equals 800. Again, what does that look like? That's 150 plus 250 is 400. 400 plus 400 is 800. So that's fair enough. That's pretty easy, right? 800 is my total. Okay. Now that I found I know what my total voltage is, I found my total resistance, I can now find total I. And all I need to do, guys, is pretend that that I is not there. What kind of problem is that? Well, that's a division problem. V divided by R. So that is 12 divided by 800. So in my calculator, that looks like this. 12 divided by 800 equals 0.015. See that? All right, so now I know. 0.015. Great. So now that I know my total current, remember the rule? Current is constant. I can go ahead and plug this in all the way around. Again, where do I find that? Right here. Current is constant. Okay, so let's go ahead and plug that in. That is 0.015. That is 0.015. And that is 0.015. Okay, all the way around this thing, the current is 0.015. It's constant. But here and here and here at our three resistors, this voltage is going to drop. Okay, we will see a drop in that voltage. Okay, so let's go ahead and check this first one. Well, if my resistor is 150 ohms, my current is 0.015, and I'm trying to solve for this, well, what do? I just simply cover that up. Okay, and what am I covering up? I'm covering up the V. Forgot to erase that, didn't I? Okay, so what am I covering up? I am covering up the V. Okay, can't see that V. So what kind of problem is that? I times R. So 0.015 times 150. Okay, so let's go ahead and get to our calculator. Close that out. So 0.015 times 150 equals 2.28. Okay, I'm going to take those out, and I'm going to write this in 2.28. This one. So I got to do the same thing, except this resistor is 250. All right, so clear that out. So 250 times 0.015 equals 3.75. Okay, and then the last one is 400, and my current is still the same. So let's go ahead and do that one. All right, so 400 times 0.015 equals 6. Boom. Now, how do I know? How do I verify all of this? Well, all I got to do then is look here and make sure that I add this and this and this, and it should come close to 12. Okay, so again, I want to check this one out real quick. I feel like, did I write something wrong? Let's do that again. So that one's 0.015 times 150. 2.25. Whoops. I thought I messed that up. Sorry, guys. You guys are like, wait, wait, it's not 2.28. Okay, so now we're going to add these up all the way around the board. All right, so 2.25, 3.75. Add that up. What is that? Well, that's 6. Right? And then 6 plus 6 is, you guessed it, 12 volts. So I must be correct. That's a series circuit. Pretty straightforward, pretty easy. Okay. The next one here. So I did another one with them, guys. Okay. That's this one here. Why don't you guys go ahead and give this a try, show it to me in class, and then you guys will be ready for the quiz. Okay. Again, how do I start this thing? Well, let's look. I got 9 volts. So my total is 9 volts. Oops. Sorry about that. 9 volts. Remember that pi? Okay. All right. So that rule states what? We just add up the resistors, right? So that's 100 plus 200 is 300. 300 plus 350 is 650. So I put that in, 650. Boom. Okay. Then, now that I know that, what am I solving for? Yep, trying to solve for I. Sorry for my dog barking out there. I wish people wouldn't let him out, but he's a beast. All right, to solve for I, just cover it up, pretend that it's not there, right? Whoop. What kind of problem? V divided by R. All right. And so what does that look like? That is 9 divided by 650 equals, oh my goodness, crazy number, right? So we want 3 digits, guys, so that'll be 0.014. We'll round it up right there, okay? So we bring that in. Go ahead and put that in, 0.014. And then, if you remember the rules, what's constant? Current. So I'm going to put 0.014. I'm going to do that all the way around. And then I have to calculate for V. Okay? Why don't you guys give that a try? Show me in class. When you show me that you have completed both of these, you walked it through, you showed your work, I will give you the quiz that you are missing. Okay? All right, guys. Good luck. Peace out.